Hey, good morning, everyone. Today's lesson is on the law of sines. This is a great formula to help us find angles and sides in triangles, and not just right triangles, but any kind of triangle. So it's even better than sine, cosine, and tangent, because with sine, cosine, and tangent, we're restricted to solving for angles and sides in right triangles. Before we maybe start with law of sines, let's just do one quick example. You don't have to write this down, just kind of watch this. We're doing an example with cross multiplying. If we have x divided by 15 equals 10 over 40, I want to solve for the value of x. And what I want to do is I want us to do this two different ways. Traditionally, what we do is we take our information and we go 40 times x, so the top number times the bottom number, equals 15 times 10, right? Top times bottom, keep the equal sign, and then we want to solve for x, so we end up going divide by 40, and now we have an equation of 150 divided by 40, and we can use decimals for our answer, and 150 divided by 40 is 3.75. So that's kind of your traditional cross multiply. Always look at top times bottom and find your answer. What I want us to think about is the fact that we really just want to solve for x. And if I want to solve for x, what I want to do is just try and get that x by itself. So if I want to get x by itself, I don't really need to move the 40, because if you look at our first situation, if I move the 40 to begin with, what I ended up doing was putting the 40 right back to where it started from. So I want us to kind of think about that when we're solving for an equation. In this case, solving for x is, if the x can be isolated without having to move the other number, then let's not move that second number. So let's just go 10 times 15 divided by 40. It doesn't change any of the math. We still end up with 150 divided by 40. But we're starting to do some of that problem solving planning and looking forward to the next step. So it doesn't matter which way we're going to solve our problem, but we're going to try and use this green thinking. If I want to solve for a variable, let's do less work instead of doing more work. So the key thing here again is that we want to look at, how does cross multiplying work with something called the law of sines. What we see is we have a bunch of ratios: a over sine A, b over sine B, and c over sine C. And let's just draw a little diagram in terms of what we mean by a over sine A, b over sine B, and c over sine C. We're going to name our triangle. It doesn't matter which one is A, which one is B, and which one is C. We want a big A, a big B, and a big C. We all want to always talk about little a being opposite big A, little b being opposite the big B, so the side opposite the angle, and then little side C opposite angle C. So that's real important for us to understand. So someone way back when realized that these ratios are all equal to each other. And because they're equal to each other, we can set them up and we can use our cross multiplying skills. So this is kind of the key thing here. We're going to cross multiply to solve for either sides or solve for angles. And much like we did with some of our review yesterday, when it comes down to time for solving for angles, we have to just make sure that we tell our calculator to go backwards. So let's write the formula. So I always like to write my formula: a over sine A equals b over sine B equals c over sine C. Start with a formula. So if you started with sine, cosine, and tangent yesterday, those are the same things that you would kind of follow that process when you're doing the new formula: a over sine A, b over sine B, and c over sine C. Our a value, we don't actually have to work with. Our b value is what we want to solve for. This is our c value, 9.5. Angle B and angle C, and angle A we're not going to work with. So we're not going to work with the a's. So we can actually just say we're not going to work with the a's. We just want to work with the b over sine B and c over sine C. So if we talk about what b is, that is our unknown. We want to solve for b. And sine of b is where we're going to put sine of 68. And then little c is the 9.5. and sine of c is going to be sine of 48. So this looks very much like that little practice cross multiplying question that we did before we started the sine lesson. So what we're going to do then is what we're going to show you is changing the sine 68 and the sine 48 to decimals, and then just working with numbers. You don't have to change these to decimals. If you just want to work straight away with the numbers, we can. We don't have to change them to numbers. But let's go numbers. So I have b, and sine of 68 is 0.9272. That's the ratio for sine of 68. 9.5 is already a number, so leave it at 9.5. And then sine of 48, let's change this to a number as well, 0.7431. Cross multiply to find side b. So we're going to take the sine ratio of 68 degrees, 0.9272, times that by 9.5, and divide that by the sine ratio of 48, which is 0.7431. So let's take and let's multiply those two things together. The sine of 68.9272 times that by 9.5, and divide it by the sine ratio of 48, which is 0.7431. And looking at our question, C was one decimal place, so let's find little b to one decimal place. So the length of side b to one decimal place would be 11.9. 11.85 rounds up to 11.9, and these are in meters. So law of sines, if you can write a ratio and you can look at the numbers that are in your ratio, very quick and very easy to work with in terms of cross multiplying. So start with your formula, identify what information is given to you, put the numbers into the formula, figure out how you're going to cross multiply to isolate for your unknown value, in this case the side b, and then solve. I'm just going to take a second here to shrink the information that we have, and then we can work on the next example. That wasn't very good. Let's just undo that. And I'm just going to pause here for a second. Sorry about that. We're going to take this information, we're going to shrink it here so it fits for this question. Okay, let's look at the second example. Well, we don't have A, B, and C this time, so let's just change our formula to go with D, E, and F. We want to talk about side D, opposite of D. We got angle E, so we got side E. We have F, so we have little f. If I want to write this formula out, kind of look at the pattern we had before. Whatever letter was on top, A was with sine A. So if I want to follow that pattern, D is going to be with sine of D. E is going to go with sine of E, and F is going to go with sine of F. So letters don't matter. It's all about the idea that the side and the sine ratio get to make a pattern, and that pattern is the formula we're going to use to solve for our unknowns. Looking at the question we have this time, we're only going to work with the D's and the E's, so we don't have to work with the F's at all. So let's put in everything that we know and solve for the unknown value, which in this case is going to be angle E. So D is 12. Sine of D is going to be sine of 68. E is 10, and E is going to be sine of theta. We got a little theta symbol there, so we can use theta. So this is kind of like working your calculator backwards in a sense again now, because we got to find the angle, but the cross multiplying part doesn't change. We want to isolate sine theta. How do I get this expression by itself? So what we're going to do is we're going to look at these two numbers, the 12 and the sine theta. we're going to trade places with them. We're going to put the sine theta where the 12 is, because that's kind of like cross multiplying. If I have 12 times sine theta, I have to divide by 12. So the 12 and the sine theta actually trade places. So the sine theta is going to be the number that's going to be by itself, and the 12 now has gone to the bottom. So by cross multiplying, those two basically multiply each other, and then I would have to divide by 12 to get sine theta by itself. The top expression is going to be 10 times by the sine of 68. And again, I can change sine of 68 to a decimal number. So I don't have to work with sine of 68. I can go 10. Again, the sine of 68, we found that in the last question, was 0.9272 divided by 12. So if I change this to a decimal, 10 times by the sine ratio of 68 degrees and divide it by 12, I have sine of theta, 10 times 0.9272 divided by 12, I get 0.7727. Now, how do I change that to an angle? I got to tell my calculator I want to work backwards. I want to change this decimal number, 0.7727, change it to an angle. So I use my second function. I use my shift function. There's lots of ways for me to I guess know how to use my calculator. Some of us have second sign, some of us have shift sign. But if I round this off to the nearest degree, I get an answer of 51 degrees. So the law of sines can be used to find angles. The same way as we kind of use sine, cosine, and tangent to find angles, I need to have a ratio. I need to have a decimal number. And then second sign, shift sign, inverse sign, whatever button on your calculator has your calculator work backwards, that's how you find the angle. So that's kind of it. You can find sides, and we can find angles using the law of sines. I'm going to stop it here and give you guys a chance to do the next couple of examples on your own, and then from there we should be able to do a worksheet.